Okay, guys, so the very first lesson in this chapter had to do with unit rates. So we talked about unit rates, and we talked about how we basically have two different types of units, and you get the one unit down to one. So for example, like 67 miles in 1 hour, or over 1 hour, becomes 67 miles per hour. Then, of course, our second lesson, which was our last lesson, had to do with using our unit rates and being able to use that knowledge to find out whether or not relationships are what we call proportional or non-proportional. So today what we're going to do is we're not going to talk about if something is proportional or non-proportional. These things are actually proportional. What we're actually going to do is they're going to give us some proportional information, and we need to find out a missing number. Okay, so for example, let's say we have, I don't know, 3 pounds of meat that's going to cost us $6, and if they say, well, if all the meat is proportional in the cost, if 3 pounds of meat costs $6, how much would 5 pounds of meat cost? And so we'd have to find, of course, the cost of 5 pounds of meat. So that's kind of what we're doing today. But we're going to start off very easy, and there's a couple of words. So if you don't have your notes out already, go ahead and grab your notes. We need green on the left and notes on the right. Green on the left, notes on the right. We actually have 2 words today, or 1 word and 1 phrase, but both in our vocabulary notes. All right, the very first word is proportion, everyone. Okay, so when I talk about proportion, we just, right, last lesson we talked about the word proportional. Well, the suffix al, of course, changes it to an adjective, but bottom line is that it's very much the same. Proportion is just the noun form. Okay, so here's what your book says a proportion is. It's an equation stating that 2 ratios or rates are equivalent. So in your little box over to the right, go ahead and write this. It looks like 1/2 equals 2/4, but figuring that we're talking about ratios and rates, it would be a 1 to 2 ratio is equivalent to 2 to 4 ratio. But that is, because they're equal, it says that this is a proportion. Okay? So if these were fractions, you'd call them equivalent fractions, but because they're ratios, we say that they're proportional, or this is a proportion. Okay? So for example, it would be something like, just kind of keeping in the idea of meat, for example. Well, you know what, instead of meat, let's talk about what we talked about a couple of lessons ago, and that is like having, it'd be like having 1 desk for 2 students would be equivalent to having 2 desks for 4 students. Okay? So we have proportion, and then we have something that is a skill that you may or may not know, but we're going to talk about it today, and that skill that we're going to use is called cross product. Everyone? Okay, so here's what the definition of cross product is in your book. It says the product of the number of one ratio and the denominator of the other ratio. The product of the numerator of one ratio and the denominator of the other ratio. Then it goes on to just say the cross products of any proportion are equal. So if we, let's just say this, okay? Back in elementary school, and even what you've seen me used up to this point so far this year, if we had something like this, and let's say we were adding fractions or subtracting fractions, and we needed common denominators. And at one point when you're doing that, to find a common denominator, let's say we get a common denominator of 4. Now we have a missing number up here. What you've seen me do, and what I'm sure you did in elementary school, is if you take this number, one of the rules, and it's an easy rule, is if you take this number and you find out how to get from this point to this point, or in this case, we just take the 2 and multiply it by 2. Now a rule says, of course, is if you use the same product in the numerator spot, you'll get 1 times 2. You'll get that equivalent fraction. Okay, so 1/2 is equivalent to 2/4. Okay. However, the problem is as we get older, you're not going to always have something that looks like that. So for example, what if we have something that looks like this? We don't know what this is. Now you can put like this old-fashioned box up here. I'm going to put x because we're 7th graders now, right? So we have our 2/4 equals x over 6, and we need to know what is that. Well, I tell you what, 4 times what is 6? Well, 4 times 1 is 4. 4 times 2 is 8. We don't have an integer that we can multiply with 4 to get 6. So here's what we have. Okay, let me go ahead and share with you guys. Okay, back in the past, mathematicians realized they found a pattern among equivalent fractions, or in this case, proportions. All right, talk about ratios. So for example, we'll just keep with the idea of fractions. 1/2 equals 2/4. Okay, or even something less. I mean, I could put a different one. 1/3 equals 3/9. Okay, well, here's what they realized. If they took a bunch of different equivalent fractions like this, they realized a little something that was consistent with all of them. If you took these two numbers that are diagonal from each other and you find out the product of them, meaning multiply them, 2 times 2 is 4. But if you take a look, if you do it the other way, you're going to get the same cross product. So the same thing could be done here. 3 times 3 gives us 9. 9 times 1 gives us 9. If fractions are equivalent, cross products are going to be equivalent. And that's what it says here. The cross products of any proportion, these can be considered proportions if we're talking about ratios, they're equal to each other. Now you might be thinking, well, Mr. Wilkins, okay, so what does that mean? Well, if I take a look here, I know that this times that is going to give me the same as this times this. Why? Because of that equal sign right there. Now, here's what we're going to do. To be able to find out what x is, okay, here's what we're going to do. I'm going to write down exactly what I just said. This times this, that times that, right? 6 times 2, is going to be the same. The word the same in math means equal. It's going to be the same. The product's going to be the same as this times this. So 4 times x. And guys, what we have here is we have, I don't want to call it a one-step equation, okay? But once we simplify this side here, it will be a one-step equation. So if I simplify it, 6 times 2 is 12. I end up with 12 equals 4x, which is a one-step equation. So if you remember right with one-step equations, if you remember from elementary school, okay, you find your variable. We need to isolate it, meaning get it by itself. The way you do that, of course, is to do the inverse. Okay, in this case, x is being multiplied with 4. The inverse, or the opposite, I'm going to divide by the 4. And whatever you do to one side of the equal sign, we do to the other. And we have that canceling out. X is equal to 3. Okay, now I know that maybe you looked here and you realized that x was equal to 3, but be careful, okay? Don't fall into not listening to me anymore, because the numbers that we're going to have in just a bit are going to be harder. I'm just using a simpler example for you to see how that works. And of course, x is equal to 3. And that should make sense for us, because 2/4 reduces to 1/2, and so does 3/6. So that's how you find out a missing number using the idea of cross products. So in your notes, in the little box, go ahead and let's write this down really quickly. 2/4 is equal to 3/6. And just do this. 4 times 3 is 12. 6 times 2 is 12. And that's just an example how cross products are the same. They're equivalent. All right, so with that said, let's go ahead and let's grab our books. And please flip over for our examples. Flip your book over to page 58. Page 58. All right, page 58. Eyes up here as soon as you're ready to go. Okay, on page 58, okay, problem number 2. I'm going to go over here for right now. Problem number 2 looks like this. We have 3 2/10 over 9 is equivalent to, and they tell us, n over 36. Now listen, I do understand on some of these you might be able to use your elementary type skill, but that's not what we're doing today. We wouldn't have had the vocab word cross products without trying to get good at it. That's what our objective is using cross products to simplify or to solve these proportions. All right, so here's what we do. All right, here we go. Step 1. Okay, step 1 is we're going to go ahead and use cross products. Use cross products to write an equation. So for example, right, we're going to go ahead and our cross products here is this times this. By the way, I'm going to write my equation over here. So 3.2 times 36. Remember, is the same as this times this. The same or equal to 9 times n. Now step 2 is I need to solve this equation. Now listen, I'm going to put a little star here because remember, sometimes we need to simplify the sides, okay, or one of the sides of the equation, one of the expressions here. So I'm going to go ahead and simplify this side. Okay, it's going to take a little extra work here, so I kind of go over to the side, use what I can call like scratch paper work. So 3.2 or 3 2/10 times 36. 3 2/10 times 36. All right, so ignore my decimal with multiplication of decimals. 6 times 2 is 12, carry the 1. 6 times 3 is 18, plus 1 is 19. I'm moving over 1 because I'm now going to be multiplying by 30. So I put 1 0 down. So 3 times 2 is 6. 3 times 3 is 9. All right, so I go ahead and add. We have 2 plus 0 is 2, 9 plus 6 is 15, carry the 1, 9, 10, 11. Now don't forget, we have a decimal here. There's 1 digit to the right of the decimal, so in my answer, 1 digit to the right of the decimal. So what we have is we have 115 2/10 is what the product of that is, okay? A little harder than the problem we just did a little while ago in our vocabulary. And now, guys, I just continue to solve. So here's my variable. All right, there it is. It is being multiplied with 9, so I'm going to do the inverse. I'm going to divide by 9. I'm going to do the opposite. So divide by 9 there, and then I'm going to divide by 9 here. And when we do that, wherever we did the opposite, those are going to cancel. That's how we isolate the variable, meaning get it by itself. And now the answer to this problem right here is going to give us our answer of what n actually is. So 115 2/10 divided by 9. So 115 2/10 divided by 9. A little bit of long division. It's a single digit divisor, so that's nice. 9 doesn't go into 1, but it does go into 11. I could build a little wall here. Okay, 9 goes into 11 without going over just one time. So I put 1 right next to that line, that wall, okay, right above that second 1 and 11. 1 times 9 is 9. Subtract, I get 2. I'm going to bring down my next digit, a 5. 9 goes into 25. Well, not 3 times, that'd be 27, so it'd have to go in twice. 2 times 9 is 18. Notice I put the 2 over the 5 since I brought the 5 down. I go ahead and subtract. I can borrow if I want, and I get 7. And my last digit comes down, and and I now have 72, which I like because I know 9 goes into 72 exactly 8 times. I put the 8 over the 2 I brought down. 8 times 9 is 72. No remainder. Don't forget, bring your decimal up. And ladies and gentlemen, n is equal to 12 and 8 tenths. So just a quick reminder, right? We have our proportion. Using cross products, write my equation. So 36 diagonal from each other, right? 36 times 3.2, right there, is equal to 9 times n. And now we have an equation. If you need to, simplify one side and then solve your equation. Okay, so here's what I'm going to do. I'm going to turn around and I'm going to give you a little more than 1 minute, all right, to go ahead and try out problem number 1 on your homework on page 59. All right, go. Okay, 30 seconds. Go ahead and turn to your neighbor. Okay, here's what I would like you to do. When you turn to your neighbor, please, you could start by sharing your answer. Okay, but what I'd really like you to do before you, or maybe even after you share your answer, I don't care which one you do first, I want you to compare equations. This equation is very important. A lot of people struggle with going from the proportion to the equation. So make sure, take a look at our answers, but also the equation. All right, 30 seconds. Turn to your neighbor and share. Go. Okay, so on your homework, here we go. Number 1, we had our proportion. Our proportion was 1.5 over 6, 1 and 5 tenths over 6. Okay, and that is going to be equal to 10 over P. All right, so step 1, right? Use cross products, write the equation. So here we go. 6 times 10. All right, 6 times 10. Is the same or equal to 1.5 times P, 1 and 5 tenths P. So now, remember I have my equation. Step 2 is solve. I might need it, the star was to simplify possibly one of the expressions. This one's a lot easier than the last one, right? 6 times 10 is just 60. So we turn around and we take a look, and now I just have a one-step equation. Remember, this was multiplication. So is this. I'm going to do the opposite. I'm going to divide by, in this case, 1.5 here and 1.5 here, 1 and 5/10. So these cancel just like the 9s did there. I end up with P this time around instead of the N. And then I have my division. So 60 divided by 1 and 5/10. Remember, bottom into top. That's what we're doing, bottom into top. So here we go. Now the problem is I have a decimal in my divisor. That's the outside number. So remember, in elementary school, when you have something like that, you need to get rid of it. So move it to the right however many times you need to get rid of it. In this case, it's just once. Whatever we do to the divisor, we do to the dividend. So I go ahead and go to the inside and do the same thing. Move it over once. Anytime, most of you guys know, anytime you have a loop like that, right? It's creating a 0. So I now rewrite my problem, and I have 600 divided by 15. Now, 15 can't go into 6, but it can go into 60. And we talked about this the other day. 15 goes into 60. Well, it's like having 15 minutes into 60 minutes, which is an hour. I know that there's 4 sets of 15 minutes in an hour. 4 times 15 is exactly 60. Now, be careful. Some of us forget to do this. When we bring a number down, we have to divide into it. So 15 goes into 0 just 0 times. 0 times 15 is 0. And our answer, ladies and gentlemen, P is equal to 40. All right. So now here's what we're going to do. All right. Let's go ahead and let's take a look at, keeping with your homework, let's take a look at problem number 4. Problem number 4 on page 59. Okay, now the directions on these say assume the situations are proportional. So we're not finding out, it's just saying they are proportional. All right, it says write and solve by using a proportion. So guys, here's what all this is. All this is this is a word problem to one of these. That's all it is. So I'm going to show you how to take a word problem and convert it basically to a proportion. And then from there, solve it just like we did here. So here we go. Number 4, okay, says, if you read this with me, number 4 says, Everardo paid $1.12 for a dozen eggs at his local grocery store. Determine the cost of 3 eggs. Well, here's the thing. Okay? First of all, if you remember right, we're going to start this the same way we did during our unit rate lesson, during our word problems there. So here's what we're going to start with. Step 1 is we're going to find our rate. We're going to find our rate. And our rate, remember, is basically taking 2 quantities, all right, with 2 different units, so 2 numbers with 2 different units, and we're going to write them one over the other in fraction form. Okay? And remember what I told you when we did this. I said most of the time, especially in 7th grade, a lot of the times they're going to be in the same sentence. The 2 related pieces of information are going to be in the same sentence. So for example, I take a look at the very first number they give me, and it is $1.12. Okay? Now what I'm going to do is say, okay, well, if I reread that, Everardo paid $1.12 for a dozen eggs at his local grocery store. Be careful. All right, there is another number in there, and that number is a dozen. It's 12. And so I could ask you, well, what was $1.12? Well, it was for the dozen eggs, or the 12 eggs. So 12. Now, I'm going to go ahead and put a little star here because we need to make sure that we write the units with it. All right, that when we're setting up our proportion. Okay, and here's why. Okay, step 2 is I'm going to write exactly what I just said. I'm going to finish off my proportion. And I'm going to put a little star here, and from the star I'm going to draw a little arrow. That's because I'm going to make sure that my units remain constant in this case. It's dollar signs on top, the word eggs on the bottom. Now here's why. Because step 3 is they're going to ask us for something or to find out something. And they're going to give us some information in this. So if I take a look at the very last sentence, it says determine the cost of 3 eggs. Now, don't be tempted to put 3 on the top, because the 3 in that story right there is asking for the cost of 3 eggs. So I'm going to go ahead and plug that in. And what we have here is we have our proportion. And from here on out, guys, step 4, I'll go ahead and draw a little boxing this off here, but step 4, I'm just going to put the word solve. And what solve means is I'm going to go and do step 1 and step 2 from our previous problems. And that's all we're doing. So steps 1, 2, and 3 are basically setting everything up correctly. And now we're just going to solve using an equation. So here we go. I'm now just focused in on my numbers. 3 times 112, so 3 times 112 is, remember, equal or giving us the same as 12 times, I don't know what this is. Again, we could put a box here. I'm going to use a 7th grade variable in x. So in this case, 12 is the same as 12 times x. So 12 times x. And now, remember, I'm going to go ahead, I'm going to simplify this side. So 3 times 112. I'm going to come over here really quickly and go 112 times 3. So 3 times 2 is 6. 3 times 1 is 3. 3 times 1 is 3. Decimals over twice, so over twice we get 3 and 36 hundredths equals 12x. One-step equation. X is being multiplied with 12, so I'm going to divide by 12 here and here. These cancel. As soon as I find this out, I'm going to get my x, which is, of course, the amount of money that 3 eggs are going to cost. So I'm going to go ahead and do my division. 3 and 36 hundredths divided by 12. 12, I'm going to ignore my decimal point. It's inside there. 12 goes into 33. Well, I know that 3 dozen is 36. That'd be too big. So I'm going to say 12 times 2. Put the 2 over that last digit there. That gives us 24. When I subtract, I get 13 minus 4 after I borrowed. I get 9. I bring down my 6. So I can cover up and say 12 goes, I could go, so 1 goes into 9 times. But here's the thing. Well, I tell you what, I could try that. So 12 times 9, that's 18. 9, oh, that's too big. So 12 times 8 is 16. 8, look at that, perfect. 8 times 12 is 96. Don't forget your decimal. Please bring it straight up. Put a 0 there. And here's what we have. 0.28. However, do not forget, this is a word problem. You can even consider this step star here. And because it's a word problem, we need our units on our answer. And the question was, determine how much 3 eggs are. Well, there's our units right there. Put your dollar sign on that. And in this case, $0.28 means 28 cents for 3 eggs. Okay, so I'm going to go ahead and I'm going to give you guys a couple of minutes to try one of these out. And the one I want you to try is the very next problem on your homework, which is problem number 5 on page 59. Problem number 5. All right, so I'll give you a couple of minutes. Go. Okay, 30 seconds. Go ahead and turn to your neighbor. And what I would like you to do when you share, I want you in this case, you could share your answer again, but in this case, I also want you to share two other things. I want you to share your proportion, and I want you to share your equation. So those three things are very important. So go from here, share your proportion, and then your equation. All right, 30 seconds. Go. All right, so problem number 5. Page 59, problem number 5 says, Sheila mixed 3 ounces of blue paint with 2 ounces of yellow paint. She decided to create 20 ounces of the same mixture. How many ounces of yellow paint does Sheila need for the new mixture? Okay, so here's what we have. We're going to write a rate, okay, with 2 important pieces of information. All right, so we want to go with, we can go 3 ounces of, and listen, we have 3 ounces to 2 ounces, but don't put ounces. That's not what we want. We want a description of what they are. We want to separate the 2 parts of this. So it's 3 ounces of blue, 2 ounces of yellow. Okay, now here's the problem, and this is definitely a little bit of a twist to this. Okay, take a look at what the question says. It says she decided to create 20 ounces of the same mixture. Right? Now they throw this in on you, but look, we have only blue and yellow. The mixture means both of them together. So here's the thing, they turn around and ask, how many ounces of yellow paint do we need? So here's what we need. We do need the 2 ounces of yellow paint, but we don't need the blue paint. We need the mixture. And the mixture is them put together. Well, guys, it's not 3 ounces, right? It's 3 and another 2, which is 5. So yeah, this one was a little tricky. That's why I wanted to do this in class. So what I have here, I'm going to rewrite this. It's 5 ounces of the mixture to 2 ounces of the yellow. So what I have now is they say they want to know, she wants to make 20 ounces of the mixture. 20 ounces of the mixture. Right? So we write our rate. I have my mixture on top, my yellow on the bottom. Look at my 20 ounces of the mixture goes on top. I just did step 3. Now step 4 is I'm going to solve. So here we go. I go ahead and say, okay, 2 times 20 is the same as 5 times, I'll put x there, so 5 times x. And now I simplify, right? I simplify this side. 2 times 20 is 40. Equals 5x, and this is nice and easy, right? No major division here. We're going to divide both sides by 5, and we have, when that cancels, x equals 40 divided by 5 is 8. So if we do this, it is 8. Now don't forget your units. 8. How much of yellow? Because that's what the question says, right? How many ounces of yellow paint does Sheila need for the new mixture? 8 ounces of yellow. Okay, a little tricky on that one. All right. Okay, so here we go. There is one last kind of problem here. Okay, let's take a look. Let's take a look at. Actually, let's skip number 4 in the guided practice part. Let's go straight to your homework. Let's take a look at problem number 6. Okay. 6 and 7 and 8 are all going to be very similar on your homework. Okay, problem number 6, the directions are actually different.
Abigail Espanilla, please come to the Rayburn office. Abigail Espanilla, please come to the Rayburn office.
The directions say assume the situations are proportional. Okay, just like we have here, it means we can write a proportion. But then it turns around and says use the unit rate to write an equation and then solve. So actually, they're not asking us to write a complete proportion and solve it like we've been doing. They want us to do it a little bit differently. And so that's why I want to do this one with you. So here we go. All right. So number 6 says a car can travel 476 miles on 14 gallons of gas. Write an equation relating the distance d to the number of gallons g. How many gallons of gas does this car need to travel 578 miles? So they're asking us to do a couple of things here. So here we go. I'm going to start you out. Okay. Step 1 is write the rate again. Write the rate. So the rate is very similar to everything we've been doing. It's 476 miles to 14 gallons of gas. Notice I put the units there. Now, the directions say use the unit rate. So we're going back to our unit rate. We're going back to our unit rate lesson. And meaning that, remember, the bottom is 1. So basically how many miles per gallon are we going to go? Well, we're going to divide both sides by 14. Top and bottom, I should say. So 14 divided by 14 gives us a 1. 476 divided by 14, well, it's a bit bigger. I'll come over here. All right, so 14, well, let's see. If I cover up the 7 and the 4, I go, okay, 1, just to estimate. Let's try 14 times 4. Let's see what that is. 14 times 4, that's 16. Carry the 1. 4 plus 1 is, okay, too big. 14 times 3. That's 12. 3 plus 1 is 42. So it's going to go in 3 times. I put the 3 over the 7. That's 42. That's 7 minus 2 is 5. Bring down the 6, and I like that. Here's why, because we just did that problem. 14 goes into 56 exactly 4 times. So it's 34 miles per gallon. Now, that is, of course, what step 2 would have been, was find the unit rate, because that's what it was asking us. Okay, and that's what we just did. So step 1 is write the rate out of the problem. Step 2 is find the unit rate. Okay, now here's where it gets a little different. All right, step 3 is it wants us to write an equation. Now, there's a number of different ways that we can do this. Okay, and but here's an equation. First of all, we know has an equal sign in it. Now they give us, as part of this equation, they give us 2 variables that represent something. Okay, and those variables, if you take a look, is the distance, which they say is d, and the gallons, which is g. So here's what we're going to do. I'll put the distance, the d on one side, and I'm going to put the g on the other, because there's a relationship between the two when we go to solve this. All right, so we're going to go ahead, and that is what step 3 is. Take your 2 variables they give you. They're going to be a relationship between the two, so put them on each side. Now we know that they actually have meaning behind it. D is the distance, G is the gallons. Distance being, of course, miles, G being the number of gallons of gas. Okay, so what we're going to then do is this. We're going to turn around, and this is a little tricky. This requires some thought. I'm going to put a bubble, kind of like a brain, around step 4, because this is where mental math comes in. Here is what you're going to do. Now, if it's 35 miles to 1 gallon, ask yourself, and I'll put a question mark right here because that's what you need to ask yourself. How far do you go on 2 gallons? Okay. Or you can even say, if you go 34 miles on a gallon, well, I'm trying to think of a different way to tell you this, but if I sit here and say this, well, what am I going to do? I'm going to multiply I'm going to turn around and multiply the 2 gallons by 34 to find out, right? If I'm using 3 gallons, what am I going to do? I'm going to multiply the 3 with 34. So what am I doing? Every time I'm multiplying the gallons by the 34 to get how far I'm going to be able to go. So what I just said, what came out of my mouth, and this is the hard part of this problem, is I'm going to multiply the number of gallons with the 34. So to be able to do that, to show that, I'm going to go ahead and put the number 34. Why? Because I'm going to multiply 34 with however many gallons I have to find the distance traveled. Now, here's what they do. They turn around and they ask you one more problem. And guys, this is the first answer. That's the first answer to what they want in our homework. They then say, how many gallons of gas does this car need to travel 578 miles? So here's what we have. This is step 5. We have D is equal to 34G. They give us 578 miles. Guys, be careful. That's not our G. The miles are the distance. 578. I'm going to plug it in for D equals 34 times G. And we have a one-step equation once more. Divide both sides by 34. And we end up with G is equal to whatever that is. So this is our division problem. 578 divided by 34. Now, I'm going to go into 57. Now listen, 30 times 2 is 60. So 34 times 2 is bigger than 60. 34 is only going into 57 one time. So when I subtract, I get 2, 3, and 8. Now I'm going to go ahead and cover up the last digit. 3 goes into 23 7 times. Let's try that. 34 times 7, 28. That's 21 plus 2 is 23, and look at that. Guys, G is equal to 17, or G is the number of gallons, and if you take a look, it says how many gallons of gas does this car need to travel? So our answer, guys, is 17 gallons. And that's your second answer. All right. So, a little solving proportional relationships.